Hi, I'm Mohan Atreya from Rafay Systems. In this video, we will look at how you can deploy and operate Amazon EKS distribution, aka EKS-D, on AWS Snowball Edge devices. We will first start with a brief introduction to AWS Snowball Edge. Then we will look at how to provision and manage Amazon EKS-D on Snowball devices. We will then look at common use cases for Kubernetes on Snowball Edge type devices. Finally, we will see some demos of critical capabilities in action. AWS Snowball Edge is part of the Snow family. It is particularly optimized for edge computing. The compute optimized Snowball Edge devices are extremely well resourced with 52 CPUs, 200 GB memory, and about 42 terabytes of storage. They can also be configured with an optional GPU if required. Administrators can use AWS provided resources to manage and administer the Snowball devices themselves. Rafay helps streamline the provisioning and ongoing operations of Amazon's EKS-D and your containerized applications on AWS Snowball devices. The use of Rafay managed EKS-D on Snowball Edge enables a number of extremely interesting use cases. This configuration is particularly well suited for a distributed fleet of clusters, locations with intermittent and/or limited connectivity. Rafay provides centralized management and orchestration using a zero trust security model that ensures that the Snowball Edge devices can operate behind firewalls and do not require any inbound connectivity for management. This secure dial-out architecture allows Rafay to easily scale and manage hundreds and thousands of remote clusters. Let's move on to demos now. We will first start with what a Snowball Edge device looks like. Next, we will look at how you can provision and operate a fleet of EKS-D-based Kubernetes clusters on Snowball Edge devices. That Rafay provides both a declarative and an intuitive wizard-type graphical interface for provisioning. Once the EKS-D cluster is provisioned, users can view and monitor their remote clusters using the integrated dashboards. As you can see, this dashboard clearly indicates that the cluster is running an Amazon EKS distro and the Kubernetes version is version 118. What we're seeing now is a cluster dashboard where the administrator can easily and quickly view things like CPU utilization, number of workloads, number of pods at a glance. A node level dashboard also is provided where all the metadata associated with nodes is instantly available at the fingertips for an administrator. If necessary, they can also dive deeper into a node level dashboard where they can look at the number of nodes, number of resources available on the particular node. Administrators can also instantly, at a single click, view all the Kubernetes resources available on the cluster and view the appropriate metadata associated with their pods and other Kubernetes objects on the cluster. They can also use the troubleshooting capabilities integrated in the Rafay platform for zero trust kubectl operations. Application owners can use GitOps to deploy and operate workloads to a fleet of hundreds or thousands of remote EKSd clusters in minutes. They can also remotely troubleshoot and debug their workloads using the Rafay console. Developers can make a simple change in the Git repo and have that automatically updated and reflected on all the managed clusters for that workload in minutes. In this example, the change to the Git repo has initiated a GitOps pipeline, and once the approval stage is approved, the workload is automatically updated. Learn more about Rafay by visiting our website at rafay.co or email us at info@rafay.co.